Yes. So, students. So, let's start with lecture number 1 for mechanical properties of fluids, class 11, physics. Oh, first of all, we discuss what is a fluid. Anything which can flow is a fluid, right? Obviously, most of the metals, most of the solids, they don't flow except mercury at normal temperature. But then all the liquids and all the gases at NTP, normal temperature and pressure, they both flow, and hence both together, liquids as well as gases, are termed as fluids, right? Well, the fluids flow is very interesting for engineering and other point of view. So what is the main characteristic of a fluid? See, students, imagine if this is a table, and on this table this is some block. Now this is a solid block. All right, let's see. Somehow this block is hinged to the bottom, right? It's hinged to the bottom, so you can say it is fixed with the bottom. Now, students, if you apply a force here, I'm not talking about the force being applied like this. I'm only talking about the force being applied on the upper surface, on the, this is the upper surface of the solid, this surface. So when you apply this force on this surface, what will happen? This surface would slightly get deflected. So I'm showing little more, maybe less than that also. So this point will come here, right? So this will be the new shape of the solid, right? So when this surface, this point, let's say this point is A, the A gets changed by A dash. So let's say A dash is delta x. This distance. This distance is delta x, and this is, let's say, L. So I define shear strain as delta x by L. I also call it theta in radians. This is shear strain. Now, similarly, if this is a force applied here, students, this force is Fs, right? Now, this force Fs, it's shear force divided by the area on which this force is applied will give me the measure of shear stress. I write it as tau s. So tau s is what? It is shear stress. Now, why I explained this, students? In case of solids, in case of solids, this phase of the solid offers some resistance against the shear force, right? Every solid, let's say this is some rubber block, and let's say the bottom of the rubber block is again hinged or it is fixed to the surface. Then if you apply some force here, obviously the deflection will be more. In case of rubber block, it will become like this, but still you can say this surface, this surface, upper surface of the rubber, or the rubber as a whole, it offers some resistance against Fs. What is Fs? Fs is shear force, right, students? We have so many forces, like let's say this is a rod. So if you try to extend this rod, or you can say if you try to stretch this rod like this, if this force is applied at two ends in opposite direction, is known as tensile force. And in case the force is opposite, trying to compress the rod, it's known as compressive force. And together, tensile force and compressive force, they are known as longitudinal force. Very, very important for you to understand. Longitudinal force. So these are like different, These forces are always applied perpendicular to this surface. See that. This is perpendicular, but it's not the case with shear force. Shear force is always applied along this surface. Shear force is always applied along the surface, whereas these longitudinal forces, that is tensile force and compressive force, they are always applied, yes, perpendicular to the surface. Very right, okay? So you say if this is a surface and you apply this force, this may be a longitudinal force, but if you apply the force along the surface, now this is a surface, let's say, right? So this will be the shear force. So students, fluids. Fluids have very, very less resistance in case you have fluid in this container. Is it stationary? Or let's say in this tube, fluid is flowing. So there is very, very less resistance, negligible resistance a fluid body offers against the gradual or sudden impact of shear force. So this is important characteristic or perspective of fluids. All right, students. Now we go ahead and we define what is pressure. So till 10th standard, we had our own understanding about pressure, that is force by area. Okay. But then students, let's say this is a plane surface. Now if I apply this force on the surface, right? The question is, will it create pressure on this area? The area on which this force is applied? So the answer is yes as well as no. Now, students, we know that every force has a component, or we know that every force can be resolved along two components along x and y axis, right? If this is some vector f. Now, this can be the x component of x, and this can be the y component of f, right? Using that, this force has vertical component, and this vertical component, which is making 90-degree with this plane surface, does create pressure on this surface, right? Very, very important thing. Or you can say f, this is f, then f sine theta, right? F sine theta would be responsible for creating pressure. All right. Another thing, students, if I have a liquid, let's say this is some liquid in this container, and if I dip some inclined surface in this liquid, all right. Now, this, what we're going to explain, is related to what we have explained here. Once again, you see, if this is a plane surface and there are forces acting at some inclination, so the vertical component of these forces would, let's say if this is theta, all these forces are inclined at angle theta, so their vertical component, you know, acting on these points would be responsible for creating pressure. Okay, so once again, one surface, the surface is not inclined. The force is inclined, right? So force is inclined, we take its vertical component, that creates pressure. Here we have another thing. Here the surface is inclined. Now we want to understand in every fluid, whether it is liquids or gases, this surface of the this body, it has so many surfaces. Now it will experience pressure all around in all the directions from this fluid, right? So we want to see that in which direction. You see, pressure is, thrust by area. No, we will not say force by area. We will say thrust by area. And thrust is always perpendicular to the surface, right? If the surface is inclined, so this would be the thrust on this surface. Am I right? Okay. So if this is an inclined surface, so students, interestingly, on this surface, the the liquid will exert force in this direction. On this surface, the liquid will exert force on this direction. On this surface, in this direction, and from the bottom, the liquid which is there below this surface will exert the force again at 90 degree. So on a whole, we can conclude, if this is a container, and let's say we have this some body is there, which is having inclined surfaces. So the liquid will exert force on all the inclined surface and perpendicular here and here. It's very, very important understanding, and this is related to this also. All right, students, a little bit more in-depth understanding of this can be explained here. See, if this is the surface, now there are so many fluid particles. You see, there's a fluid particle here, there's a fluid particle here, there's a fluid particle here. Now this fluid particle is applying this force, then it's applying this force, then it's applying this force. you know it's applying so many kinds of forces on the surface, and now this point also is applying the force like this on the surface, and this forces cancel with each other. So what is left is basically only the perpendicular component. So you think about this more, and you understand that the liquid all around the surface will only exert the pressure perpendicular to its inclined surface. All right, so this is also done, and then we have a small numerical. Let's say this is a girl, and the mass of the girl is, let's say, 30 kg, and the girl is wearing heels, and the surface area of her heel is, let's say, 1 centimeter square. This is a numerical from your NCERT book. So we want to see how much pressure she's standing on the floor. So how much pressure she exerts on this surface. So see that, students. First, you know that mass is 30 kg. So what will be the weight of the girl? So weight of the girl is mg, right? So that will be 30 into 10 would be equal to 300 Newton, right? Weight of the girl will be 300 Newton. Now this 300 Newton is total weight, or you can say 300 Newton is the total force applied by the earth, attracting this girl toward its center. So this force will get divided 150 Newton here, 150 Newton here. So this force which is acting downwards is only 150 Newton. Don't make the mistake of taking 300 Newton. So what is the pressure on the surface? Now the pressure on the surface would be thrust by area. So obviously this is 90 degree. So we can take this entire force. So it is 150 Newton divided by area is 1 centimeter square. Well, that is equal to 1 into 10 raised to power minus 4 meter square. Am I right? So this is equal to 150 into 10 raised to power minus plus 4 Pascal. All right, so this is approximately equal to 15 bar. So you see that atmospheric pressure is approximately equal to 1 bar. So each heel of the girl is exerting the pressure approximately equal to 15 times the atmospheric pressure on the floor. Thank you very much.